Here's a mistake that happens all the time. You see that student A scored 2 points higher than student B, and student B scored 2 points higher than student C. The mistake is jumping to the conclusion that student A must be significantly better than student C. But when we actually look at the numbers, A is only 4 points higher than C. Not a huge difference at all. This is exactly why we need to understand the transitive property of inequalities. In this video, we'll learn the correct way to handle these step-by-step comparisons, explore the mathematical rules that govern them, and work through examples so you never make this mistake again. The transitive property of inequalities is a fundamental mathematical concept that helps us understand relationships between quantities. When we have a chain of inequalities, this property allows us to make logical conclusions about how these quantities relate to each other. Mathematically, the transitive property states that if A is greater than B and B is greater than C, then A must be greater than C. This creates a logical chain of relationships. To understand this concept better, imagine we're comparing the ages of three people: Alex, Billy, and Carol. We'll use this relatable scenario to see how the transitive property works in practice. Here we have Alex, who is 25 years old, Billy, who is 20 years old, and Carol, who is 15 years old. We can establish relationships between their ages using inequality symbols. First, we establish that Alex is older than Billy. Since Alex is 25 and Billy is 20, we can write this relationship as Alex is greater than Billy. Next, we establish that Billy is older than Carol. Since Billy is 20 and Carol is 15, we can write this relationship as Billy is greater than Carol. Now comes the key insight of the transitive property. Since Alex is older than Billy and Billy is older than Carol, we can conclude that Alex must be older than Carol. This logical connection is what makes the transitive property so powerful. The transitive property creates a logical chain. When we have A is greater than B and B is greater than C, the greater than symbol maintains its relationship across the entire chain. This allows us to conclude that A is greater than C, completing the transitive relationship. This fundamental property works with all inequality symbols: greater than, less than, greater than or equal to, and less than or equal to. Understanding this concept is essential for solving more complex mathematical problems and logical reasoning. Now that we understand what the transitive property is, we need to explore its different variations. The transitive property doesn't just work with the less than symbol, it works with all inequality symbols. But there's an important rule we must follow. The first variation uses the less than symbol. If A is less than B and B is less than C, then we can conclude that A is less than C. This creates a chain of relationships that flows in one consistent direction. The second variation uses the greater than symbol. If A is greater than B and B is greater than C, then A must be greater than C. Notice how the direction of all inequalities remains consistent. They all point in the same direction. The third variation uses the less than or equal to symbol. If A is less than or equal to B and B is less than or equal to C, then A is less than or equal to C. This works because the relationship allows for equality at any step while maintaining the overall ordering. The fourth variation uses the greater than or equal to symbol. If A is greater than or equal to B and B is greater than or equal to C, then A is greater than or equal to C. Again, the key is that all inequality symbols point in the same direction. Here's the crucial requirement that makes the transitive property work. The direction of all inequality symbols must be consistent. You cannot mix different directions and expect the property to hold. This consistency is what allows us to create a logical chain from the first element to the last. To summarize, the transitive property works with all four inequality symbols: less than, greater than, less than or equal to, and greater than or equal to. The key is maintaining consistent direction throughout the chain. This fundamental rule will be essential as we move forward to solve actual problems using the transitive property. Now let's work through our first example to see the transitive property in action. This will be a simple numerical example that clearly demonstrates how the property works. Here's our problem. We're given two inequality statements. 5 is less than 7, and 7 is less than 8. We need to determine what we can conclude using the transitive property. First, let's clearly identify our given information. We have two separate inequality statements. The first tells us that 5 is less than 7. The second tells us that 7 is less than 8. To better visualize these relationships, let's place these numbers on a number line. This will help us see exactly how the numbers relate to each other. Let me highlight the three numbers we're working with: 5, 7, and 8. Notice their positions on the number line. Step 1. We can see that 5 is less than 7. On the number line, 5 is positioned to the left of 7, which confirms this relationship. Step 2. We can see that 7 is less than 8. Again, on the number line, 7 is positioned to the left of 8, confirming this second relationship. Now we apply the transitive property. Since 5 is less than 7 and 7 is less than 8, we can conclude that 5 is less than 8. This direct relationship is shown by the curved arrow connecting 5 to 8. This works because if the first number is smaller than the second, and the second is smaller than the third, then logically the first must be smaller than the third. The number line makes this relationship crystal clear. The key insight here is that the transitive property allows us to connect relationships across multiple comparisons in a logical chain. This fundamental principle will be essential as we move to more complex examples. Now we'll work through our second example, which involves algebraic variables. This will show you how the transitive property applies not just to numbers, but to variables as well. First, let's clearly identify our given conditions. We have x is greater than y, and y is greater than 3. Notice how these are algebraic inequalities involving variables, not just numbers. Our goal is to prove that x is greater than 3. This is what we need to establish using the transitive property. Step 1. We start with our first given condition. We know that x is greater than y. Step 2. We also know from our second given condition that y is greater than 3. Step 3. Now we apply the transitive property. Since x is greater than y and y is greater than 3, we can write this as a chain. X is greater than y, which is greater than 3. Therefore, we can conclude that x is greater than 3. This works because the relationship is maintained through the common variable y, which serves as the connecting link between x and 3. This works because the relationship is maintained through the common variable y. Think of y as a bridge that connects x to the number 3. Since x is greater than this bridge and the bridge is greater than 3, then x must be greater than 3. Now, let's discuss common mistakes to avoid. The most frequent error is reversing inequality signs or not maintaining the direction. If x is less than y and y is greater than 3, you cannot directly conclude that x is greater than 3. All inequalities must point in the same direction for the transitive property to work directly. Remember, in our example, all the inequalities pointed in the same direction. X is greater than y, and y is greater than 3. Therefore, x is greater than 3. This consistent direction is what makes the transitive property work smoothly with algebraic variables. Now for our third example, we'll explore a real-world application of the transitive property. This example will show you how mathematical reasoning applies to everyday situations. Here's our problem. John is taller than Mary, and Mary is taller than Peter. We need to determine who is the tallest person among the three. Let me show you the three people visually. Here we have John, Mary, and Peter. Notice how I've drawn them with different heights to represent the relationships described in the problem. Step 1. Let's identify our given information. We know that John is taller than Mary, which we can write as John is greater than Mary. We also know that Mary is taller than Peter, written as Mary is greater than Peter. Step 2. Now we apply the transitive property. Since John is greater than Mary, and Mary is greater than Peter, the transitive property tells us that John must be greater than Peter. Step 3. We can now conclude that John is the tallest person. Since John is taller than both Mary and Peter, he must be the tallest among the three. This works because the transitive property creates a chain of relationships. When we have John greater than Mary and Mary greater than Peter, we can link these relationships together to conclude that John is greater than Peter. Remember, this is exactly how the transitive property works in real-world situations. We use logical reasoning to connect relationships and draw valid conclusions. This same principle applies whether we're comparing heights, ages, test scores, or any other measurable quantities. This example demonstrates how mathematical concepts like the transitive property are not just abstract ideas, but practical tools we use in everyday reasoning and problem solving. Now that we've seen how the transitive property works, let's examine the most common mistakes students make and learn how to avoid them. Understanding these pitfalls will help you apply the property correctly every time. The first common mistake is confusing the transitive property with the symmetric property. The symmetric property says if A equals B, then B equals A. But this doesn't apply to inequalities. Here's the wrong thinking. If 5 is less than 8, then 8 is less than 5. This is completely incorrect. Inequalities are not symmetric. The correct understanding is that inequalities have direction. If A is less than B, then B is greater than A, but we cannot reverse the inequality symbol and keep the same order. The second mistake involves mixing different inequality symbols. The transitive property only works when all relationships use the same type of inequality. Here's an incorrect application. If A is less than B and B is less than or equal to C, we cannot conclude that A is less than C using the standard transitive property. The correct conclusion would be that A is less than or equal to C because we must use the weaker relationship when combining different inequality types. The third mistake occurs when students forget how multiplication or division by negative numbers affects inequalities. This can break the transitive chain if not handled properly. Consider this scenario. If -2 is less than -1 and -1 is less than 0, then -2 is less than 0. This is correct so far, but watch what happens if we multiply all terms by -1. Students often forget to reverse all the inequality signs, which breaks the transitive relationship. The correct approach is to reverse all inequality signs when multiplying by a negative number, maintaining the transitive relationship. Now let me share some practical tips to help you avoid these mistakes and apply the transitive property correctly every time. Tip number 1. Always check that your inequality symbols are consistent. If you're using less than in one relationship, make sure you can use less than in your conclusion. Tip number 2, double check the direction of your inequalities. Draw arrows or use number lines to visualize the relationships if needed. Tip number 3, focus on understanding the concept, not just memorizing the rule. Ask yourself why the transitive property works and when it applies. Remember, the transitive property is a powerful tool when used correctly. By avoiding these common mistakes and following these tips, you'll be able to apply it confidently in any mathematical situation. Now that we've explored the transitive property of inequalities through definition, examples, and common mistakes, let's recap the essential concepts you need to remember. First, remember the fundamental definition of the transitive property. When we have three quantities where the first is less than the second and the second is less than the third, we can conclude that the first is less than the third. Second, this property works with all types of inequalities. Whether you're dealing with less than, greater than, less than or equal to, or greater than or equal to, the transitive property applies consistently. Third, this property is incredibly versatile. It works with simple numbers, algebraic expressions with variables, and real-world scenarios like comparing heights, ages, or any measurable quantities. These three key points form the foundation for understanding and applying the transitive property in your mathematical problem-solving toolkit. If this video helped you understand the transitive property of inequalities, please give it a thumbs up. Subscribe to our channel for more step-by-step math explanations, and don't hesitate to ask questions in the comments section below. In our upcoming videos, we'll explore solving compound inequalities, graphing inequality systems, and working with absolute value inequalities. Each builds on the foundation you've learned today. Remember, mathematics is a skill that improves with practice. Try creating your own examples of the transitive property using different numbers and scenarios. The more you practice, the more confident you'll become with inequalities. Thank you for watching, and remember this fundamental relationship that connects three quantities through logical reasoning. See you in the next video.